5.10 model B. Same thing as the one above. The main difference here, not sure if you can notice it right away, but we are going down. Our concavity is going down this time. And the reason why that's a big deal is we want to pull that negative sign out. We want to factor it out. Okay. Before we get to the factoring, let's look at our y-intercept. Remember, if this disappears and that disappears, what's left over? Simply -5. So our y-intercept is 0, -5. Let's go plot that. 1, 2, 3, 4, 5. All right, now let's go into factoring. So we can pull out a negative sign, which means all of our signs are going to flip. X squared minus 6x plus 5. Box method. X squared positive 5. We only have two factors of 5. It's 1 and 5. How do we get 1 and 5 to turn into -6? Well, let's make them both negative. They're both negative. They multiply to positive 5 still, and they add to -6. So -x and -5x. Factoring out, going up, we get x to come out. X times x. X times -1 equals -x. And -1 times what equals positive 5? That is -5. So our two factors are x minus 1 times x minus 5 with a negative sign out front. That has not gone away. So we get our intercept here is 1, 0, and here's 5, 0. Let's plot those. 1 and 5. Looking at our axis of symmetry, we can tell that it's going to be in the middle of our two x-intercepts, which is going to be right here. And we can count that over, which is going to be 3. The other way to do that would be 1 plus 5 equals 6. Divide that by 2, which equals 3. 3 is going to go into our equation, so -3 minus 1 times 3 minus 5. -3 minus 1 is 2. 3 minus 5 is -2. So we have negative times 2 times -2. Well, we have two negative signs, so those are going to cancel out, and we're going to get a positive. And 2 times 2 is 4. So our vertex is 3, 4. 1, 2, 3, 4. And now let's connect our dots. I'll use my bright green. And there we go. There's our graph. It is facing down just like we should have had.